Okay, so welcome back. So these are the notes for the second target of the Pythagorean theorem unit, and by the end of this lesson you should be able to use the Pythagorean theorem with a real-world application. So there are some steps with approaching these problems. So we're going to begin by reading the problem all the way through, and then we're going to identify what we need to know and what we're solving for. That's going to lead us to drawing a picture to help us represent what sides A, what sides B, what sides C, and what their measures are. Then we're going to label those variables like we did in the first target, use the Pythagorean theorem to solve the problem, and then the only difference with these problems now is that we're going to write a sentence in the context of the problem. So if we look at our first problem here, it reads, you're locked out of your house and the only open window is on the second floor, 25 feet above the ground. You need to borrow a ladder from one of your neighbors. There's a bush along the edge of the house, so you have to place the ladder 10 feet from the house. What length of ladder do you need to reach the window? Okay, so now we're going to read through it a second time, but this time we're going to circle the important numbers. This is a helpful strategy to use because usually the important numbers either have some sort of measurement after them, like feet or meters, or they're kind of those leading factors to finding your measurements for sides A, B, and C. So again, it reads, you're locked out of your house and the only open window is on the second floor, 25 feet. So we're going to circle that first number with its measurement above the ground. You need to borrow a ladder from one of your neighbors. There's a bush along the edge of the house, so you have to place the ladder 10 feet from the house. What length of ladder do you need to reach the window? Okay, so this question is asking us to find what the length of the ladder is that we need to reach the window. So the what I need to know, or what I need to find out, is how long the ladder is. So now that we're finding for the length of the ladder, we're going to draw a picture to help represent this. So I'm going to draw my house right here on the side. Okay. And then I'm going to label this side as well. Just call it house. And then it tells us that there's a bush in front of the house, which is why we have to place the ladder so far away. So I'm going to draw a little bush on the side. And then we have this ladder coming from 10 feet away up to my house. So then, if we connect the house to the ladder, we see that it forms a right triangle. So then we're able to use the Pythagorean theorem to find the length of the ladder. So now because the ladder is placed 10 feet away, I can label this bottom side 10 feet. And it tells us that the window is 25 feet above the ground. So now I can take this information and label my variables like we did in target 1. So now I'm going to write A equals, B equals, and C equals. I'm going to set A equal to 10, B equal to 25, and then C is going to be that question mark because C is representing the length of our ladder. And now we're going to do A squared equals and B squared equals, and then 10 squared equals and 25 squared equals. And then we know that 10 squared is equal to 100. And we know that 25 squared is equal to 625. Now we're going to jot down our equation that we're using, which again is A squared plus B squared equals C squared. Then we're going to substitute this value of A squared into our equation so that we get 100 plus the value of B squared, which is 625, equals C squared. And still C squared because we have nothing to substitute in for it. That's what we're solving for. And we know that 100 plus 625 is 725. And then we carry down that C squared. And then our last step is just to take the square root of both sides. And the square root of 725 is 26.9 feet. And now our final step is just to write a sentence in the context of the problem. So we can write a sentence that says, the ladder needs to be at least 26.9 feet to reach the window. So now that we've done a problem together, we're able to take this and apply it to another type of problem. So now let's try the second problem together. So the second problem reads, Greg plays baseball at a field where the baseball diamond is a square, with each side of the square measuring 90 feet. If the baseball was thrown from home plate to second base, and then from second base to third base, how many feet did the baseball travel? So now let's read it again, and circle the numbers that are important. So Greg plays baseball at a field where the baseball diamond is a square, with each side of the square measuring 90 feet. 90 feet has a measurement after it, so we're going to circle that number. If the baseball was thrown from home plate to second base, and then from second base to third base, how many feet did the baseball travel? So here I'm not going to circle the second and third base because that's just telling us about where the traveling is in the problem. It's not really a measurement we're going to use for our formula. So now we need to identify what we need to know. So we already know the length from second base to third base is going to be 90 feet because it's a perfect square and a baseball diamond. However, we need to find the length of the diagonal of the baseball diamond because it travels from home plate to second base. So now we can use this information to draw a picture to help represent what we're solving for. So here I'm going to draw a baseball diamond. And then I'm going to draw in my plates that are used in the field. And I'm going to label them. And now I'm going to use another color to show where the ball has traveled. So it says that the ball was thrown from home plate to second base, so that's this line right here. And then from second base to third base. So that's right here. And we also know the measure of each side is going to be 90 feet. So now the only measurement we don't know is this middle measurement right here. So that's the side we're going to solve for. So if you see here, we have a right triangle. And our right triangle is going to fall on this side where I drew the green line straight up and down. We're going to use that triangle on the side. And so we're going to do the same thing that we've been doing and say that A equals B equals C equals. So we can say A equals 90, B equals 90, and C is what we're solving for. So we can say A squared and B squared both equal 90 squared. And they both equal 8,100. Now we can write down our equation of A squared plus B squared equals C squared. Substitute in the value of A squared and B squared into the equation. And then that's going to equal 16,200. And then we're going to take the square root of both sides. So then we're going to get C equals, I'm going to write this up here, guys. So C equals 127.3 feet. But if you look at the problem, it asks how many feet the baseball traveled. So since it traveled from home to second plate, and then from second to third plate, we need to add the two distances together to find the total distance traveled. So then we're just going to take 127.3 and add 90, because that's the distance from second plate to third plate. And that's going to equal 217.3 feet. And then our last step is just to write a sentence in the context of the problem. So then we're going to write, the ball traveled a total distance of 217.3 feet. Alright, and then if you guys look at your notes, there's one last problem. I want you guys to try that one independently, and then you can check your answer with the answer key in the bottom there. And remember, let us know if you guys have any questions or anything. We're always here to help.